Welcome. Let's take a look at finding the value of the limit as x approaches infinity of e to the x plus 3x minus 5, all divided by 2x. As we do this, when we find an indeterminate form of 0 over 0, or infinity over infinity, we can apply L'Hopital's rule to find the value of the limit. So as we try to apply L'Hopital's rule to this particular function, my numerator, as x goes to infinity, e to the x will approach infinity, plus 3x will also approach infinity, minus 5. So my numerator approaches infinity. My denominator, as x approaches infinity, 2x, my denominator will approach infinity as well. So we have an indeterminate form of infinity over infinity. And this is an eligible form to apply L'Hopital's rule. Now, as we apply L'Hopital's rule, we will not be using the quotient rule. L'Hopital's rule states that we take the limit of the ratio of the derivative of the numerator over the derivative of the denominator. So, applying L'Hopital's rule, we get the limit as x approaches infinity. Our derivative of our numerator is e to the x plus 3, the derivative of that 5 being 0, all divided by 2. So what does this give us? Well, in the numerator, as x approaches infinity, e to the x will approach infinity, plus 3, the numerator will still approach infinity, but my denominator is simply 2. So something that grows without bound, divided by 2, will still grow without bound, which means that this limit is infinity. Let's take a look at a second example. Let's evaluate the limit as x approaches infinity of 3x squared minus x plus 1, all divided by x to the 4th minus 4. Notice that this numerator is a quadratic or a parabola. So as x approaches infinity, the behavior of this numerator will approach infinity. In my denominator, as x approaches infinity, x to the 4th minus 4 will also approach infinity. So we have an indeterminate form of infinity over infinity. And that's a form that allows us to use L'Hopital's rule. So this is equal to, and we will write LH to indicate that what follows is the result of applying L'Hopital's rule. And we get the limit as x approaches infinity. Now the derivative of our numerator is 6x minus 1. And the derivative of our denominator is 4x cubed. Now, as we consider this limit, notice that the numerator, that function is a linear function with a positive slope. So as x approaches infinity, my numerator will approach infinity. And my denominator, as x approaches infinity, will approach infinity as well. So we again have an indeterminate form of infinity over infinity. So this new function, this new limit, is eligible for applying L'Hopital's rule again. So this equals, and we'll write LH to indicate what follows is the result of applying L'Hopital's rule. And we get the limit as x approaches infinity. Now the derivative of my numerator is 6. The derivative of my denominator is 12x squared. Now, as x approaches infinity, my numerator remains 6, and my denominator increases without bound. So as I divide 6 by subsequently larger and larger and larger values of the denominator, this limit will approach 0. I hope you find this helpful.